Lesson 13, video number 1. We're going to look through these problems. I don't have the notes right in front of me, so I'm going to do it off my computer. So the first example is taking this thing right here and writing it in terms of a single trigonometric function. Okay. Now, when we're looking at that, I'm thinking I have no idea how to do that. We have phi theta inside sine and cosine with a 4 in front of it. I don't know what I'm doing. So as always, I'm going to look back to my identity formula sheet. Okay. When I'm looking at this, I'm going to notice that there's a bunch of different identities that I can use. Now, in lesson 13, we're looking at section 6.3. That's double and half angle identities. So chances are I'm going to look at one of these two sections right here. Okay, double angles or half angles. And if we look very closely, we'll notice that the sine of 2x is supposed to be equal to 2 times sine of x cosine of x. Well, that sounds kind of familiar, okay? When I look very closely at the two of these together, again, sine of 2x is equal to 2 sine of x cosine of x, and I have 4 sine of 5 theta cosine of 5 theta. These two angles are the same. These two angles are the same, okay? The only thing that's awkward is the fact that this is a 4 and not a 2. So what I'm going to do is I'm going to write this as 2 sine of 5 theta cosine of 5 theta. In doing so, I now see that this thing right here, okay, is comparative to this identity up here, assuming that 5 theta in the identity is equal to x, okay? So with me making that statement, this thing is really supposed to be equal to 2, okay, sine of 2 times x. Well, what's x? 5 theta. So I have 2 times 5 theta. What is that really? That's 2 times the sine of 10 theta. And I have written this as a single trigonometric function, so this is done. Okay, that's problem number 2. Let's look at problem number 3. Now, in problem number 3, if I'm given that the sine of alpha is equal to 4 over 5, okay, and I have 0 degrees is less than alpha is less than 90 degrees, it's saying find the exact value. Okay, find the exact value of sine of 2 alpha. Okay, so now there's a lot of stuff going on here. All I'm really looking for is what is this? Okay, this is what I want to know. What they're giving me is sine of regular alpha, okay, and what quadrant we're working in. So let me start with that. I'm working in 0 to 90, that's 0 degrees to 90 degrees. That means I'm working in this first quadrant over here, okay? If I'm working in that first quadrant, I can drop this perpendicular, I see alpha, and now I have a triangle, okay, which sine of alpha is supposed to be 4 over 5. Well, I don't know what that value is inside the unit circle, so what I'm going to do is I'm going to identify that as a triangle, and I'm going to go ahead and work through the triangle information. Sine is opposite over hypotenuse, so therefore this side must be 3. Okay. Now I have all the information for that triangle. The only issue is this is alpha, not 2 alpha. And I can't just double everything in this, because if you recall, by doubling all the sides, we have similar triangles, and this angle doesn't change at all. Okay, so remember that. Again, you can't just double the side lengths. It doesn't work that way. Not to mention, if I consider trying to do that, I'm still going to get the same ratio when I plug it in. So, what we're going to do instead is we're going to look at my identity sheet. Okay, as always, go back to the identity sheet just in case. Now, when I look at this, we're trying to find what sine of 2 alpha is. Well, I have sine of 2x here. And when I look at it, it's equal to 2 sine x cosine x. So it would actually be equal to 2 sine alpha cosine of alpha. Let's go ahead and write that down. So this sine of 2 alpha is actually equal to 2 sine alpha cosine of alpha. Wait a second. Sine of alpha is 4/5. We identified that already. Okay, that was given to us. What's cosine of alpha? Well, if I look at this triangle, I'm going to cross this one out, okay, because I don't want to play with that one. When I look at this triangle, cosine is adjacent over hypotenuse, so 3/5. And just, this is all numbers now. By multiplying all this appropriately, I have 25 on the bottom, I have 24 on top, and I am done with that problem. Again, there's not much to these. It's just a big issue of recognizing the fact that I can't play with sine of a different angle than sine of alpha. Okay, so I need to manipulate that until I can get it into all versions of alpha. Okay, so that covers problem 3. Let's go ahead and jump to problem 4. I'm going to go ahead and do it on the same piece of paper. Okay, and we'll start it right over here. Problem 4 is verify. Okay, we're going to verify the identity. Cosecant of 2 alpha is equal to 1/2 tangent alpha plus cotangent alpha. Now, when I look at this identity, what I want to prove, okay, I'm coming to a conclusion that I don't like it. Why don't I like it? Because it's got cosecants, cotangents, and tangents. And the only identities that I have here in front of me to work with in terms of a double angle, again, notice this is a double angle, is these ones here. Okay, so what I think I'm going to do is I'm actually going to go ahead and play with cosecant of 2x so that I can utilize one of these identities in terms of double angles. Okay, so what is cosecant really? Cosecant is 1 over sine. So this is sine of 2 alpha. Okay, that's what this side is equal to. Next, I'm going to say, well, 1 over 2 alpha, isn't that just the same thing as 1 over this identity right here? Okay, so sine of 2x, I'm going to replace it with 2 sine x cosine x, where x is alpha. So this side here is going to be 1 divided by 2 sine of alpha cosine of alpha. Okay, well, there's my 1/2. I'm going to go ahead and pull that out. I have 1/2 1 over sine alpha cosine of alpha. This is supposed to be equal to 1/2 tangent alpha plus cotangent alpha. And you're thinking to yourself, well, I don't know how to get this to this. Okay, I'm going to move this over here so you can see it. I don't know how to get this piece here to this piece here, because 1/2 and 1/2, those pieces are done. We don't need to worry about those anymore. Well, what's generally the rule we like to go with? Work with the most complicated side. I actually started with the most simplified side. Why did I start with this side? Because of that double angle. I need all of the angles in all of my trig functions to be the same before I can start comparing them. So that's what I did. I transitioned it so that it was the angles of all the same measures. Now over here, what I'm going to do is work with the most complicated side. Change this all to sines and cosines. So this is 1/2 tangent is sine over cosine, plus cotangent is cosine over sine. Okay, and you'll notice with this one that if I find myself a common denominator, that being sine alpha, cosine alpha, this is 1/2 sine squared alpha, because I have to multiply top and bottom of this one by sine. Again, to have cosine times sine, I need sine and sine here. To multiply, or to get this thing down here to be cosine sine times, I need to multiply top and bottom by cosine, so this will be cosine squared. So plus cosine squared alpha is all divided by cosine alpha sine alpha. And I hope you're looking at this going, oh wait, that's a joke, because this piece right here is 1. Okay, so this is 1/2 1 over sine alpha cosine alpha, and that checks this problem off because that's what I have over here. Okay. Now again, remember, with these particular problems, there's a multitude of different methods. You have to continue to play with it until it works out nicely. The first thing to always do is check the angles. Make sure the angles are all the same in all the trig functions. Next thing to do is work with the more complicated side. Now, what I could have done is, right here, I could have started manipulating both sides. Multiply both sides by 2, multiply both sides by this thing, I'll get 1 is equal to something over here, and I could get 1 equals 1. It's what you see first, okay? Take your time with that. Play with it until it works out nicely, okay? We still have time. I'm going to go ahead and do problem 6 as well. Number 6 is a nasty problem, okay? Number 6 is saying take sine to the power of 4 alpha and write it in terms of the first power, okay? So what I'm saying is I want this with a power of 1 and no higher, okay? That's what I want, a power of 1, no higher, okay? Of 1 or more cosine functions, and this all needs to be in terms of cosine, okay? So, I have sine to the power of 4. I want to break that down to powers less than 2, 1, power of 1 only, of cosines, okay? Now, how can I do that? Well, I'm going to look at this right here, and chances are I'm going to use the power reducing on this one. Okay, and the reason for that is because if you look at the power reducing identity for sine, cosine, or tangent, you'll notice all of the identities change the angle on the inside, but it also takes the power of 2 and changes it to a power of 1. Okay, and that happens with all these. So what I'm going to do is I'm going to go ahead and use that identity right here, because I have sine to the 4th, and I know that's really sine squared alpha times sine squared alpha. Okay? With that being done, that identity, again, sitting right here in front of me, is sine squared x is equal to 1 minus cosine 2x. So this is equal to 1 minus cosine of 2 alpha divided by 2 times, again, changing this one over as well, 1 minus cosine 2 alpha divided by 2. So now I have these two things, which I have to multiply out. What I'm going to do is I'm going to go ahead and pull out the 1/4, okay, and everything in here I'm going to go ahead and FOIL it out. 1 minus 2 cosine of 2 alpha. These are fine, but when I go ahead and multiply the two together, plus cosine squared 2 alpha, this is where we have the problem. Power of 1, power of 2. This one right here needs to be changed. So what I'm going to do is I'm going to look back at my identity sheet, and there's the power reducing formula again. 1 plus cosine 2x divided by 2. I'm going to go ahead and apply that now. So this is equal to 1/4, okay, 1 minus 2 cosine of 2 alpha plus, this is cosine squared of 2 alpha, this is cosine squared of x. So my x is now 2 alpha. So in here, when I write this down, it's 1 plus cosine of 2, x, x being 2 alpha, 2 alpha. This thing is divided by 2, okay? And now all I'm going to do is simplify it just slightly. So this is going to be 1/4, 1 minus 2 cosine of 2 alpha plus a 1/2 plus a cosine of 4 alpha divided by 2. Okay, if I wanted to, I could go ahead and find a common denominator, pull this out so it's all a 1/8. Okay, common denominator would be 2, common denominator would be 2, minus 4 cosine of 2 alpha, plus 1 plus cosine of 4 alpha. Okay, combining like terms, the 1 and the 2 make it 3, and there would be 3 terms in this end solution. This is fine. Heck, you could even stop up here, because all it tells me to do is write it as cosine power of 1, no higher than 1. Okay, that's all it's asking me to do. So that there would complete problem 6. We'll go ahead and do the rest of them on the next video.